Machine learning models are not able to understand organic information such as photos, world videos, text and sentences, and language and audio that we speak. So in order to allow a computer or an AI model to understand how all that works and make sense of it, it has to convert all that data into numbers. And the first step of this is tokenization. We tokenize that input data into a normalized set of integers that represent the meaning of every token. So we see here we've got a question that was asked. I am a CS major, so I have some idea of what you're talking about here. How do we tokenize a string into integers? Do we just take the letter positions within the string or the alphabet? So the answer is the alphabet, right? You want to take into consideration every single distinct component of that string. Let's say the string here we have, I am a student, I'm learning Python, a programming language. Now we've got a sentence, a couple sentences here, right? And then below that is a tokenized version of that sentence representing a letter by letter tokenization. So we need to do this process so that way the most modern AI machine learning algorithms that exist right now, the frontier, the bleeding edge of technology mandates that all the data is transformed into numbers, so that way we can do matrix multiplications in the deep learning process. In machine learning, when we're converting a sentence into tokens, the tokenization strategy matters a lot. There are a variety of strategies that we can implement and use and build into our machine learning model. Every single model requires you to build a dictionary when you're tokenizing your tokens because you need that uniformity, right? And there are a variety of kinds. So we have a letter by letter, where it's kind of like a symbol. So you'd create an alphanumeric map or a dictionary of every letter. You could also do byte pair encoding, where you take two or more symbols within the input text and the input sentence, and then sort of extract the common one. So that way it's sort of like a compression approach that accelerates your AI model. Then you can do word level, where you take larger tokens, so just a step above byte pair encoding, where you take the whole words and those are then the tokens. Can you do sentence level? I mean, I guess you could, though you need a lot of sentences because now you're in these huge context windows that are significantly compressed. Yes, it'll work, and you could have an AI model that's really fast that it can output sentences rapidly, though you might miss out on sort of the flexibility of that AI model. Now, if we're going to take a look of an example implementation of a tokenizer for the letter by letter, where essentially here is our alphabet, right? An English alphabet here, and then we just create a dictionary of that alphabet based on the position of the letters in the alphabet. As you know, these are all lowercase, so when we input the sentence, the text data, we need to we need to lowercase it, right? So we're not missing anything. And there may be symbols in there that we don't have in our dictionary, like, periods, commas, quote marks. So our dictionary won't capture those. Something you could do is create a dynamic dictionary for all your input training data. You'll capture every single symbol that's being used, and then that will be used as a one-time dictionary generator right here. Then you take your input data, iterate over every character, and then append the position of the token in the alphabet, and that will represent essentially its index within the alphabet or in the token alphabet. And we can see an example output here of the I'm a student, I'm learning Python, a programming language, and the representation of all the tokens, all the letters. So how far can it go in terms of the number of tokens in your dictionary? Well, you can have a lot of tokens. Essentially, you can do what the modern large language models, the existing AI like OpenAI's ChatGPT and Google Gemini, they essentially have a dictionary with every word in all languages, every single word in all languages. So that way they can train a model that includes all text data from every language in the world. Now that's going to be a very big dictionary, tens of thousands of positions, right? That's a huge amount. And machine learning tokenization is a critical aspect towards, be getting started, right? We got to turn our organic real world information into numbers that the computer can understand, because we're going to be doing math on those numbers. And it's kind of hard to do math on letters and pixels of the world. So we just talked about tokenization and the varieties of strategies here. There we go. And there it goes a step further though. Now we're going beyond tokenization. So we've already done the tokenization part, right? We've already got our letters converted into numbers. So there is a way to add more context, and often these large language models and other models as well will add context, such as the position of the characters or the words, right? The position of the tokens in relation to each other. Now, often you'll get this through things like LSTMs, RNNs, recurrent neural networks, CNNs for images, and transformers, where it has full self-attention across every single token. And that full self-attention, that is, the modern approach towards the existing bleeding edge AI. Then you can go a step further by adding additional context towards meaning and relationships between words through a process called embedding, where it takes your tokens and converts each token into a vector that has an embedding for additional meaning. And essentially, it's going to allow you to imbue a lot more knowledge into the AI just based on what those words mean. Like, what kind of word is it? Is it a noun, an adverb, a verb, something that describes something? You can add that as a piece of context. You can also add relationships of words in proximity. Is it what kind of noun is it? Is it a location? Is it a person, place, or thing? So you can keep adding more and more context, and an embedding model allows you to do that pretty well. And the most modern AIs today use a combination of all these things. They'll use word level tokenization in addition to letter level tokenization, prioritizing the word level first, and if it can't find a token position for a word, it will go down to potentially byte pair and then down to letter, right? It's single letter. So that's it. It's pretty straightforward. We take a sentence or input data, such as I'm a student, I'm learning Python and programming language. You tokenize it, and then you can add context to it by changing the ordinals, essentially converting them into maybe a position encoding, so you can get the position of the letters in relation to each other using various mechanisms, right? LSTM, RNN, transformer. Then you would also use embedding to add additional. Yeah, so that's the order of things. And then you run it through deep learning, and you've built an AI.